Have you ever wondered how AI systems learn to solve problems they've never seen before? Like how a model could look at a brand new puzzle and figure out the rules without being explicitly told. That's the holy grail of artificial intelligence, generalization. Today, we're diving into a groundbreaking study that reveals how neural networks can be fine-tuned to tackle this challenge. The problem: traditional AI models excel at pattern recognition, but struggle when faced with novel tasks. Enter the abstraction and reasoning corpus, ARC, a benchmark that forces AI to think like humans by solving puzzles with minimal examples. It's like a test where the rules aren't explained, you have to deduce them on the fly. Researchers tested two architectures, DARC, a standard recurrent convolutional network, and DAMP, which adds a critical twist, a multi-layer perceptron (MLP) that mixes information across data channels. Think of it as a chef's secret ingredient, blending flavors or data features to create a more robust model. The results: DAMP absolutely dominated. On familiar tasks, it achieved 92% accuracy versus DARC's 78%. But the real breakthrough was in out-of-distribution scenarios, unseen challenges. DAMP nailed 14.5% of these, while DARC managed just 2.3%. It's like a student acing a test. They studied for versus a peer who barely passes a completely different exam. Why does this matter? This study shows that a small architectural change, adding a channel mixing MLP, can unlock dramatic improvements. By enabling the network to learn flexible, rule-based patterns, we're closer to AI that adapts to real-world unpredictability. And the best part? Both models use the same base structure, proving that innovation often lies in clever design tweaks. Now here's where it gets fascinating. The accuracy scores formed a bimodal distribution. Instead of a smooth curve, results clustered at 0% and 100%, no middle ground. This means the models either crushed tasks or failed catastrophically. Why? It suggests the system is either super confident and right or completely clueless. This pattern challenges traditional metrics like Cliff's delta, which understate the true impact of DAMP's 7.9% accuracy boost. The secret sauce: DAMP's gated MLP. While DARC uses 3x3 convolutions to mix channels, DAMP's MLP takes this further, enabling it to grasp complex abstract patterns. This isn't just about accuracy, it's about generalization. Imagine an AI that learns from a few examples, like a human. While we're not there yet, this research is a critical step toward RKGI. Looking ahead, combining DAMP with hypernetworks, AI that generates its own weights, could create systems that adapt to new challenges rapidly. This isn't a full solution, but it's a leap forward. So what's the takeaway? Sometimes the smallest changes yield the biggest breakthroughs. As we refine these models, we're inching closer to AI that thinks, adapts, and solves problems like us. Thanks for watching, stay curious, and let's keep exploring the future of AI together.